So up until now, we've been using the difference quotient to find the derivatives of functions, which we discussed are the slopes of curves at instantaneous points. So we know that the difference quotient is a pretty tedious process to go through, and it takes a long time. And so we're going to look at some ways that are more time efficient to take the derivatives of certain functions. And the one that this video is about is called the power rule. Let's get started. So if I have this function y equals x, when I put this derivative operator here, what I'm essentially saying is, can I take the derivative with respect to x of this function y? So the power rule, and I'll just write that here, states that if you have a function that is in the form of um, x to the n, okay, let's just say that you have that, and you want to take the derivative of that. You want to find, and this is the derivative, this is prime notation, you want to find the derivative of that function. All you have to do is you have to multiply the function by whatever value is in the exponent. So that's n in our case. And then we have x. And then when you get to the exponent, writing it down, it has to be n minus 1. So once you've taken the derivative, you have to have subtracted 1 from the original exponent. And so if we do an example, what we can do here is, let's say that f of x equals 4x squared. Well, that means that the derivative of that function f of x is equal to 2 times 4, which is 8, x to the second power minus 1. And we can just write that as 8x. Therefore, the derivative of the function 4x squared is equal to 8x. So as you can tell, it's much easier to differentiate a function that is a power of x using the power rule than it is to use the difference quotient as you have been doing up until right now. Thank you all for viewing another episode. Make sure to click like and subscribe, and I will see you guys on the next episode.